Hello and welcome back to the channel. Today we're talking about time. Time is often seen as an ever-moving arrow, but it also vibrates with rhythms and cycles. In other words, it has harmonics. In music, harmonics are higher frequency overtones that resonate at integer multiples of a fundamental tone, and so the harmonics of time refers to the reoccurring patterns and cycles that resonate through history, nature, and our lives. From the swing of the pendulum to the swing of the seasons, time reveals itself in repeating intervals. Many cultures have long recognized these rhythms. For instance, Western culture has traditionally viewed time as linear, a finite resource with a clear beginning and end, often described like money that can be saved, spent, or wasted. In contrast, many Eastern and indigenous cultures see time as cyclical and abundant, repeating in endless loops of days, seasons, and generations. In a linear mindset, the future is a target that we race towards. In a cyclical mindset, tomorrow will eventually circle back around. These differing perspectives show that time is not just a physical concept, but also a cultural one. Yet across these perspectives, there's a shared intuition that time has rhythm. Even in everyday speech, we talk about the beats or flow of time. What if we look at time itself as kind of a wave with peaks and troughs and harmonics? Today, we're going to blend science, history, and philosophy to explore these harmonics of time. We're going to look at the fundamental cycles in nature and biology and how modern physics views time, from quantum ticks to relativistic warps, and how consciousness perceives time's melody. We're going to travel back to ancient wisdom, sacred calendars, and temple alignments to see how our ancestors tuned into cosmic time. We'll use musical harmony to understand time's patterns and consider practical impacts from medical chronobiology to sound therapy, and even stretch our minds a little bit to ideas like the harmonic multiverse and the 4D hyperuniverse, and time within the 4D hyperuniverse. By the end, I hope to synthesize these ideas and highlight our human connection to the cosmic rhythms that surround us. Time, in all of its mysteries, is just more musical than we ever imagined. So let's begin with some fundamental concepts that'll resonate throughout our journey. We'll often measure time by counting repeating cycles: the swing of a clock's pendulum, the vibration of a quartz crystal, the oscillation of an atomic transition. In fact, the very definition of a second is based on the vibration of atoms. Since 1967, 1 second is defined as the duration of 9,192,631,770 oscillations of a cesium-133 atom's radiation. In essence, our most precise clocks tick to the tiny harmonic vibrations of atoms. This reveals a deep connection between time and periodic motion. We perceive time's passage by comparing it to something regular and cyclic: a heartbeat, a blinking second hand, Earth spinning once on its axis. Time as a wave is an intriguing way to think about it as an oscillation rather than a straight line, with natural ups and downs like a sine wave. Many phenomena in nature exhibit cycles that give time a wavy character. Day and night form a 24-hour rhythm due to Earth's rotation. The year swings through the seasons because of Earth's orbit. A 365-day cycle with a little fractional wobble that gives leap years. And the moon's orbit around Earth creates the monthly cycle of lunar phases and influences tides. These are like the fundamental frequencies of our world's clockwork. On top of them, there are more harmonics. For example, a 7-day week is an artificial cycle, but it shapes our human life deeply. Interestingly, it also echoes the quarter phases of the moon, 7 intervals, a harmonic subdivision of the lunar month. Life itself has evolved under the influence of these periodic changes. The field of chronobiology studies biological rhythms, and as it turns out, almost every living creature dances to time's drum. The most famous is the circadian rhythm, the roughly 24-hour cycle in our physiology and behavior, guided by the day-night light cycle. Your body temperature, hormone levels, alertness, and hunger all rise and fall in daily waves. There are also longer and shorter rhythms. Human sleep cycles, 90-minute cycles of deeper and lighter sleep, the ultradian rhythms, and many animals, including us, show monthly or seasonal cycles. Ladies, I think you know what we're talking about here. Think of seasonal breeding in animals, or mood changes in some people during winter with seasonal depression, or during the full moon when lots of crazies happen to go to the ER. Even on the scale of a lifetime, we see these phases of growth, reproduction, and aging. One could poetically call these Dante harmonics of lifetime. Time's wave-like nature appears in geology and climate as well. Earth's climate has warm and cool cycles. Ice ages come and go in tens of thousands of years. The sun has an 11-year sunspot cycle, a periodic rhythm of solar activity that affects space weather here on Earth. It's as if time contains many entwined melodies, some quick, like the beating of wings of a hummingbird, and some very slow, like the drift of continents that are measured in millions of years. Crucially, harmonics means that these cycles can synchronize or resonate. Sometimes cycles align constructively. For example, if the daily cycle and the seasonal cycle coincide, long summer days versus short winter days, this can amplify or diminish certain biological effects. But recognizing these cycles help us live better in harmony with time. Our ancestors, without modern clocks, tuned their activities to natural cycles. Sunrise and sunset dictated work and rest. Seasonal cues dictated planning and harvesting. They understood time's cyclic aspect intimately because it was necessary for survival. So, before we move on, to sum up some of these fundamentals, time behaves in cycles at every scale, and we use those cycles to measure and make sense of it. This toroidal view complements the linear narrative, and I'll show you why later, and suggests that we experience forward motion often through recurring patterns, just as a complex musical note is made of a bass tone plus harmonics. The flow of time may be seen as a composite of many frequencies, from the spin of an electron to the orbit of a galaxy. When we peer into the world of physics and the cosmos, time becomes even more intriguing, almost like a shape-shifting rhythm that can stretch, shrink, or even stand still depending on the circumstances. In classical physics, think Newton, time was a perfectly regular drumbeat in the background, steady, absolute, and the same everywhere. But in the 20th century, revolutions of relativity and quantum physics absolutely shattered that picture. So let's start with relativity. Albert Einstein's gift to our understanding of time. Einstein showed that space and time are woven together in a four-dimensional fabric called space-time, and that fabric can stretch and ripple. According to this theory of general relativity, time is not an immutable tick-tock. It flows and differentiates at different rates depending on speed and gravity. A clock moving fast, say on a spaceship, will tick slightly slower than relative to a stationary clock, and this is called time dilation due to high velocity. And a clock deep in a gravitational field, say at sea level, ticks slightly slower than one on a very high mountain, because gravity actually warps time. And this is absolutely not just a theory. This is something that they have to measure and account for. GPS satellites, for example, have to correct for these relativistic effects. Their clocks in orbit tick faster than clocks on Earth. That's due to weaker gravity and their motion. And if it's not corrected, the positioning calculations would drift disastrously, off by about 10 kilometers per day of error. Relativity taught us that time can stretch like taffy in the presence of this gravity and high speeds. Time has a flexible tempo. Near black holes, its intense gravity can slow time down dramatically. In theory, at the edge of a black hole, at the event horizon, the time outside the observer nearly stops. This is kind of a cosmic super slow-mo, a far cry from the universal metronome that Newton imagined. Einstein's equations also predicted something even more fantastic: gravitational waves. These are literally ripples in space-time, propagating outward like waves on a pond. When massive objects like black holes or neutron stars collide and merge, they send out vibrations in the fabric of space-time itself. These vibrations make distances oscillate, and since time and space are linked, you can think of time itself as wiggling a bit as the wave passes. In 2015, scientists at LIGO first detected these gravitational waves, hearing a faint chirp from two black holes merging 1.3 billion light years away. It was as if we heard the universe ringing a giant cosmic bell for the first time. While the effect on time for us was minuscule, the stretching compressing of time was on the order of 1 part in 10 to the 21st power, which is unbelievably tiny. It confirmed, however, that time can behave like a wave under certain circumstances. So now, shift from the cosmic scale to the quantum realm, the subatomic world of particles, and we find an even different puzzle. In quantum mechanics, time is treated as an external background parameter. It ticks uniformly while particles and waves evolve. Unlike relativity's malleable time, quantum theory time is more like a fixed beat that everything dances to universally. And this creates a big scientific head-scratcher. Our two best theories, quantum mechanics for the very small and general relativity for the very large, have fundamentally different concepts of time. Reconciling them into a theory of everything has proven challenging, often dubbed the problem of time. Some intriguing new ideas are emerging. One suggestion for quantum physics is that time might not be fundamental at all. It could emerge from something even deeper. In 2024, a group of researchers explored an idea first posed in the 1980s, called the Page and Wouter mechanism. Their study suggested that time could be an illusion woven from quantum entanglement. Entanglement is the ghostly connection between particles that can link their states. The idea here is that if you have a quantum system to act as a clock and it's entangled with another system, the correlations between them can produce what we perceive as time. Time is effectively in an unentangled, isolated system, nothing changes. Time effectively doesn't exist for it. It's as if the universe is completely frozen. But when entangled with a reference, a sequence of change, or time, emerges. As one physicist in the study put it, the correlation between the clock and the system creates the emergence of time. This is cutting-edge theoretical stuff here. We're basically asking if time itself might be a sort of harmony arising from underlying quantum relations. If true, and that's still a big if, it's poetic. That time might be akin to a beat that materializes only when there's something to keep time with. It's the universal observer. There's also talk of quantum time crystals. Yes, crystals. Time. This sounds sci-fi, but in 2016 and 2017, researchers like Nobel laureate Frank Wilczek proposed and then observed this time crystal behavior in certain quantum systems. A time crystal is a phase of matter that exhibits a sustained periodic oscillation or motion in its lowest energy state without consuming any energy. Essentially, a system that spontaneously breaks the usual rule that things at a minimum energy are static. It's as if this system has a clock-like oscillation just by its nature. These time crystals oscillate at a fraction of the driving frequency, like hitting a system periodically and it responds at a different period. While not time travel, time crystals show that time-based periodic order can exist similarly to spatial crystal order. It underscores how deeply connected oscillation and time are in physics. Even quantum matter can find a beat to groove to. Our view of time in cosmology also presents grand cycles. One ancient idea revived in modern physics is the cyclic or oscillatory universe, the notion that the universe could go through repeated expansions and contractions. The Big Bang, the Big Crunch, rinse and repeat. While the standard view is an ever-expanding universe from a single Big Bang. Alternatives, like Roger Penrose's conformal cyclic cosmology, propose that what we think is the end of one universe might seed the beginning of a new one, in a timeless, transcendent way, giving an endless succession of aeons. Other theories imagine multiple Big Bangs or bounce backs. Though these ideas are speculative and debated, they echo an ancient intuition that perhaps time itself on the largest scale isn't linear, it's circular. And finally, relativity introduces a philosophical quandary. If time is just another dimension like space, we can imagine that the entirety of history of the universe laid out in the block universe, where past, present, and future all coexist in four-dimensional structure. Here, the flow of time, or the feeling of now, is an emergent illusion of consciousness rather than a fundamental property of physics. Einstein himself, reflecting on the death of a friend, wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. To a physicist, all moments might be equally real, like all frames of a movie reel exist, even if we perceive them sequentially. It's a mind-bending concept. Time's passage might be a bit like a melody that we hum as we move through the already written score of space-time. And that raises all sorts of questions about determinism and free will, which we'll touch on later. In summary, physics and cosmology reveal a rich, complex portrait of time. It's not a uniform metronome ticking the same for everyone, everywhere. It's more flexible, like an interactive phenomena, capable of stretching in gravitational groove, of entangling into existence and rippling across the cosmos, and perhaps of repeating across eons. Time, in physics, has harmonics in a literal sense, cycles, oscillation, waves, and in a figurative sense, different versions of time for different observers, all part of one grand composition. As we journey onward, keep this strange and scientific perspective in mind. It'll complement the biological, music, and further theoretical views of time's harmonics. Time operates externally, in clocks and cosmic phenomena. It's also deeply internal, perceived and created by our minds. We've all felt how elastic and subjective time can be. An hour can race by or drag on, depending on what we're doing. So, let's explore how consciousness experiences time, how the brain keeps its own beat, and how states of mind can alter the tempo of time's song. Humans, and likely many animals, have an innate inability to sense duration and sequence. Remarkably, the brain has no single time organ or dedicated time-stamped neurons. Instead, psychologists and neuroscientists find that our sense of time is a distributed process. The brain uses many overlapping mechanisms, sort of like an orchestra with multiple instruments. One theory is that the brain tallies time by a counting of pulses of neural activity, effectively running multiple stopwatches for different tasks. Another idea involves the concept of the specious present, a window of a few seconds that our consciousness treats as now. Essentially, our brains may integrate information over a short interval, say 2 to 3 seconds, to form a present moment experience. Everything before that window feels like past, and everything after is anticipated future. Our perception of time can be dramatically altered by context and emotion. For example, strong emotions can modulate the internal clock. In a dangerous or high adrenaline situation, people often report that time slowed down. A classic anecdote is that during a car accident or extreme sport mishap, you recall the event in slow motion. Part of this might be memory. Emotional arousal leads to laying down extra vivid, slow, detailed memories. But part is attentional. When we're highly focused, we sample more information per second, making the moment seem rich and prolonged. Conversely, time can fly when we're having fun, because our attention is so engrossed that we don't notice the clock, only afterwards to say, wow, where did the time go? On dull days, or when we're waiting impatiently, every second seems heavy because our attention is on the passing of the time itself, stretching it out subjectively. Psychology experiments confirm that some of these intuitions, for instance, stimulant drugs like caffeine or amphetamines, tend to make people overestimate the internals. The internal clock runs faster, while sedatives or alcohol can make us underestimate durations. The internal pacing slows down, demonstrating biochemical influence of ticking of our neural metronome. Even body temperature can have an effect. A slight fever can make time feel as moving more quickly, whereas being cold can make it feel a little slower. Our brain's timekeeping is a living clock, sensitive to metabolic and emotional states. And there's also a fascinating interplay between time and attention. When we pay full attention to time, staring at the second hand of a clock, the first moment can feel elongated, a phenomenon called stopping the clock illusion or chronostasis. You might have noticed this. If you glance at a clock and the second hand seems to freeze briefly before moving, that's your brain adjusting to its temporal expectation. It effectively backdates the start of your perception, creating the illusion that the first second lasts longer. What this tells us is that our perception of the present is constructed, even a bit edited by our brain. Altered states of consciousness often come with altered time perception as well. In meditation practice, experts often report a timeless feeling. Minutes or hours can feel like an instant, or occasionally a moment can feel vast. Meditation trains attention in specific ways, either deeply focused or broadly open and accepting, which can either collapse the sense of time or remove the usual markers that we use to gauge time's passing. In extreme cases, psychedelic experiences are also known to distort time. A few minutes can feel like an eternity, or vice versa. This might relate to how these substances alter neural firing patterns and network synchronicity in the brain. Essentially, it messes with the brain's internal timing circuits and narrative assembly. Even in dreams, we can experience what feels like hours, but only minutes pass in real time. The brain somehow compresses or improvises its own time sequence, a whole storyline into a brief REM sleep episode. It's as if our consciousness can create its own timeline independent of physical time, under certain circumstances. Another aspect of time and consciousness is synchronization with others. Humans are social creatures, and remarkably, when people interact or do things together, their physiological rhythms sync up. Ladies, you also know what I'm talking about here. Studies have shown that during group activities, from soldiers marching to musicians performing an ensemble, or even audiences listening raptly to a story, heart rates and other signals can become synchronized amongst the group. If a piece of music has a strong beat, the listener's breathing and subtle movements might unconsciously align with that rhythm. Audiences at live concerts have been observed to exhibit synchronized heart rate variability, especially at emotional peaks of the performance. On the neural level, when people engage in conversation or collective rituals, the brainwave patterns can also show increased coherence. This is called brainwave entrainment or neural synchrony. It's as if on a biological level, we can share a timing, common pulse. Think about when you've been in a crowd clapping to a beat. Initially, it's chaotic, but very quickly, a unified clapping rhythm can emerge. Or consider dancing. In a nightclub or a cultural dance, every moon moves in time to the music, eventually aligning their internal clocks to an external beat. This external rhythm can bind a group's sense of time together, creating communal temporal experience. Ever notice how an hour in dance class or a concert can feel very different than an hour alone? Part of that is the group synchrony effect. On a more personal level, synchronizing to nature's time is also a key to consciousness and health. Earlier we mentioned circadian rhythms, our internal clock that keeps a roughly 24-hour cycle but needs the daily signals like morning light to stay aligned with the actual day-night cycle. When we fly across time zones, this alignment breaks and we experience jet lag. Essentially, our conscious timing, sleeplessness, hunger, alertness cycles is out of sync with local time. Until we resynchronize, which might take a few days of exposure to the new daylight schedule, we feel groggy or are awake at odd hours. This is consciousness experiencing disharmony in time, a literal phase mismatch of our brain's harmonics with the environment. Over the long term, chronic misalignment, like for night shift workers or people in polar regions with long dark winters, can even lead to health issues because so many bodily processes depend on that. The ancient Greeks had two words for time, chronos and kairos. Kairos meant chronological sequential time, the number of minutes and hours, the quantitative aspect, and kairos meant the qualitative moment, the opportune or meaningful time, like when we say the time is ripe, or having a sense of timing for when to act. Our consciousness lives at the intersection of both. We keep track of chronos with our inner clocks and routines, but we live for those kairos moments when time seems to stand still or everything clicks. If you've ever been in the zone, or in a flow state, like a musician lost playing a guitar or an athlete in peak performance, you might lose sense of time passing. Chronos fades, yet every action feels perfectly timed and appropriate, kairos in full effects. Neuroscientists observe that the parts of the brain that track self and time can downregulate, while focus intensifies. It's as if the conscious brain harmonizes so well with the task at hand that clock time just gets out of the way. So our perception of time is a subjective harmony created by our brain processes. It can speed up or slow down or momentarily pause depending on the mental state, emotional, and attention. We also have the capacity to entrain with external rhythms with each other, creating a shared time experience. Consciousness actively experiences time. In a very real sense, it composes time. Each of us carries an internal tempo, and while the true time of physics might be tick-tocking steadily, or not, as we saw even physics isn't so sure, the time we live in our minds is wonderfully malleable. The human dimension of time's harmonics will be important to remember as we journey next into the past to see how ancient people understood and harnessed time cycles long before atomic clocks or EEG machines existed. Long before modern science, ancient civilizations around the world were deeply aware of time cycles and harmonics. They observed the sky carefully, built elaborate calendars, and erected monuments aligned to celestial rhythms. To our ancestors, time was sacred, tangible, and woven into the very environment and spiritual life. So we're going to explore how ancient knowledge reflects the concept of harmonic time, from sacred calendars to the repeat and grand cycles to temple alignments that capture special moments in the solar year, and the philosophical idea of time as a great wheel. One of the most famous ancient timekeepers is the Mayan calendar. The Mayan and other Mesoamerican peoples developed an astonishingly precise system of interlocking calendars. They had multiple cycles running in parallel called the Tzolk'in, or 260-day sacred calendar. It consisted of 20-day names and 13 numbers cycling like gears. Separately, a 365-day solar year calendar tracked the seasons. These two cycles meshed together to form a 52-year cycle called the full calendar round. Any given combination of sacred day and solar day repeats only 18,980 days. In practical terms, the 52 years was significant. It was roughly a lifetime in those times and the end of a grand calendar round. It was as if the world was reset to the same configuration at the start of that cycle. The Maya also had the long count, a quasi-linear count from days from the mythic start date in 3114 BCE, which acted like an astronomical reckoning of very long periods. In the long count, the famous end of the 13 Baktun cycle occurred December 21st, 2012. A lot of buzz about the Mayan apocalypse at the time, which wasn't really an apocalyptic belief in Mayan culture, just the end of one great cycle and the start of another. Kind of like how we just entered the age of Aquarius. Doesn't mean that astrology predicts the ends of ages, we just moved into another one. For the Maya, time was deeply cyclic yet nested, like cycles within cycles, harmonics within harmonics. Each day had qualities, each cycle had gods associated with it, and divination and social rituals were timed according to where one was in the overlapping rhythms of time. Similarly, ancient Hindu traditions conceptualized the time in immense cycles called yugas. There are 4 yugas that repeat: the Satya Yuga, the Treta Yuga, the Dvapara Yuga, the Kali Yuga, which together span millions of years, and larger cycles called the Klapas that encompass the creation and destruction of universes. In these philosophies, time is a wheel, often depicted as the wheel of samsara, the cycle of birth, death, and rebirth. The idea of eternal return was present. The universe itself goes through cycles of birth and dissolution ad infinitum. The cyclical view also influenced moral and spiritual life. The concept of karma and rebirth implies that what goes around comes around, literally across lifetimes. Its harmonic concept of time, one's actions set up resonances that will be felt again in the future. Ancient people also built physical structures to mark harmonic moments in time. In particular, the extreme points of the solar cycle. All over the world, you will find megalithic sites and temples aligned with the solstices and the equinoxes. Stonehenge in England is famously aligned so that on the summer solstice, around June 21st, or the longest day, the sun rises at a precise notch above the heel stone and casts a beam into the center of the circle. On that day each year, thousands still gather to watch the sunrise at Stonehenge, just as ancient people likely did, to celebrate the peak of the sun's annual journey. In Ireland, Newgrange Passage Tomb, built around 3200 BCE, older than the Egyptian pyramids, has a long tunnel leading into an inner chamber. It is precisely oriented so that at dawn on the winter solstice, the shortest day of the year, the rising sun's light flooded the chamber for about 17 whole minutes, illuminating it brilliantly. One can imagine the awe of Neolithic people gathered in darkness, then suddenly bathed in sunlight as the birth of the new sun for the year. These structures are essentially stone calendars, musical instruments in a sense that play a note, light or shadow, exactly on key dates of the year. They show how strongly ancient cultures valued attuning to cosmic time. In Egypt, many temples are oriented to cardinal directions or sunrise points. The Great Sphinx of Giza, for example, faces due east, and on the spring and autumn equinoxes, the sun appears to sit right on its shoulder as it rises. The temples at Karnak and other sites have axes aligning with solstice sunrise or specific star risings. In Angkor Wat in Cambodia, the temple's main tower is aligned so that on the equinox, the sun rises directly above it, centered in the doorway, engineering cosmic order into architecture. In Central America, the Pyramid of Kukulkan at Chichen Itza famously produces a serpent-shaped shadow on its staircase during the spring equinox at sunset. An interplay of light and shadow that ends up looking like a snake that represents the Mayan serpent deity, slithering down as a marker of the season's change. These designs aren't coincidences, obviously. They indicate that ancient builders deliberately tuned their constructions to the size cycles, creating a harmony between human activity and celestial time. Ancient calendars often mix astronomy and mythology, treating timekeeping as a sacred duty. The Chinese, for example, established a lunar solar calendar by the end of the Shang dynasty that had to reconcile the moon cycles with the solar year. They even recognized a 19-year cycle where the lunar months realign with the solar year, apparently independently discovering it around the same times as the Greeks. The Chinese zodiac, with its 12-year cycle of animal years, is another cyclical time concept, a pattern believed to influence the personality and fate. In classical Greece and Rome, dating systems were far more linear. Counting years of rulers formed a founding epoch, but they even had notions of cyclical time. The Stoics believed in the epikairos, an eventual configuration of the world at its rebirth, implying infinite repeats. The Roman poet Ovid described a cycle of the ages, gold, silver, bronze, and iron, not unlike the yugas of India. So, cross-culturally, the idea that time has harmonics and recurring themes is pervasive. And of course, another dimension of ancient timekeeping is astrology, which, setting aside its status as a proto-science, it's essentially a study of cyclical influences, planetary periods, and their supposed effects on human affairs. Astrology treated the position of the planets and stars at one's birth as a cosmic timestamp influencing personality, and moving the planets as cycles that could resonate with events, e.g. Saturn return every 29 and a half years when Saturn comes back to the place it was at your birth is traditionally a time of challenges and maturation. While modern science certainly doesn't support astrological causation, it's interesting from a cultural perspective that for millennia humans have tried to link personal time with celestial cycles, effectively seeing lives as notes in our cosmic symphony. The phrase music of the spheres comes to mind, which was originally attributed to Pythagoras and later expounded by philosophers like Plato and Kepler. Pythagoras, around 500 BCE, believed that the distance of planets corresponded to musical intervals, and thus the planets emitted a cosmic music as they moved. This musica universalis was not heard by human ears, but it was a philosophical idea that the universe was built on harmonic principles. Kepler, in 1619, trying to find an actual musical ratios in the planets' orbits. In his work, Harmonics Mundi, imagining that as planets speed up and slow down at different parts of their elliptical orbits, they sing polyphonic melodies. While these exact ideas were more mystical than factual, it's poetic that modern science did find gravitational waves. The universe really does ring, and modern string theory says fundamental particles are like tiny vibrating strings. So, at a fundamental level, the universe is musical. Ancient cultures also paid attention to chronological harmonics in history. Many believed in repeating ages or cycles of events. Some Native American traditions speak of worlds that have been created and destroyed multiple times. The Aztecs believed that we live in the fifth sun. 4 worlds existed and ended before ours. Such cosmologies impart a sense that destiny might repeat or that there are grand patterns to eras. Timekeeping in ancient societies often had a ritual and moral dimension. Consider the Jubilee concept in the Hebrew tradition. Every 50th year was a special year of emancipation and debt forgiveness, a socio-ethical reset that echoed the notion of the 7-day weeks, the Sabbat cycle, and the 7-year land Sabbat with 7 times 7 years, accumulating in the 50th year of Jubilee. A human-imposed cycle aimed to harmonize social life with a moral rhythm. It's a cool example of how time cycles were used to structure not just agriculture or worship, but justice and economic life. In essence, ancient knowledge across the world teaches us that to understand time was to understand the cosmos and our place in it. People looked for and celebrated the harmonics of time, whether it was the yearly return or the flooding of the Nile, or the 12-year orbit of Jupiter, as in some Asian calendars, or the great procession of the equinoxes. They built myths around these rhythms, the death and rebirth of gods, corresponding to seasons, the concept of an eternal return, where what is happening will happen again, giving a sense of continuity. By aligning human activities, planning festivals, New Year celebrations, coronations with celestial events, ancient cultures were effectively saying, let's play in tune with the universe's music, and recognizes the signals that it sends to us. Time was seen as sacred and participatory. By celebrating the solstice or new moon, you weren't just marking your time, you were joining in a cosmic dance. It's a perspective that modern life, with its digital clocks and time zone juggles, busy and obtuse schedules, often forget. But perhaps there's something to relearn here about living in sync with natural harmonics for our well-being. Music is the art of time organized in sound. Every melody and rhythm unfolds over time using patterns of timing to create meaning and emotion. So it's no wonder that music provides such a powerful method for understanding time itself. So how do these dots connect between musical harmonics and the human experiences of time? Consider the basic elements of music: rhythm, melody, and harmony. Rhythm is built on repeating beats, cycles of strong and weak pulses that give music its groove. Our brains and bodies are extraordinarily responsive to these cycles. If you've ever caught yourself unconsciously tapping your foot or nodding your head to a beat, that's your nervous system syncing up with an external periodic pattern. In fact, humans have an ability called entrainment. We naturally synchronize our internal rhythms to external ones. A clear example is how our heart rate can adjust to music. Listening to fast-paced songs tend to increase our heart rate and blood pressure, and a slow, gentle piece can calm your heartbeat and breathing. Studies have found that people's heart rates often synchronize with musical tempo. One paper noted that preferred music tempos fall between the 70 to 100 beats per minute range, close to a resting heart rate. And in group settings, live music can even synchronize heart rates amongst different people in the audience. As we've seen, it's as if we all start dancing internally to the same beat. This is a literal biological harmonic. The frequency of music aligns with frequencies of physiological rhythms. And now think of melody, a sequence of notes in time. A melody often has motifs or phrases that repeat or vary. It has certain notes, it has a certain timing, note durations, pauses that give it its character. In a sense, a melody tells a story in time, just as our lives do. We sometimes speak of the rhythm of life or finding your groove. Our daily routines and lifetime milestones do have a shape and pacing like a musical composition. There are fast movements, busy periods where our days blur together, and slow movements, quiet periods of reflection or waiting. A well-composed life, one might say, has a pleasing balance. Not all frantic pesto and not all languid agato. Interestingly, music theory has the idea of tempo modulation, changing the speed gradually or suddenly, analogous to how our perception of time can shift with mood or environment, as we've discussed before. At the core of this is a mathematical framework that underpins harmonics, specifically the concept of periodicity and resonance. Musical harmonics rely fundamentally on frequency ratios and repetitive cycles. When two frequencies align in simple mathematical ratios, such as 2 to 1, an octave, or 3 to 2, a perfect fifth, they produce consonant harmonies. These harmonies occur because the waveforms periodically coincide, reinforcing each other at regular intervals. This periodic reinforcement creates resonance, a physical phenomenon extensively studied in physics and acoustics. Time, too, exhibits cycles observable at scales ranging from daily routines to cosmological events. Chronobiology, the science that studies biological rhythms, confirms that human life operates within rhythmic cycles like the circadian rhythm and ultraradian rhythms, which are the shorter cycles within a single day. These rhythms are finely tuned to our natural environment, like the rotations of Earth, indicating a harmonic alignment between biological processes and planetary movement, at least our planet's movement. Research demonstrates clear health impacts when these cycles are disrupted, underscoring their importance in harmony and physiological functioning. On a larger historical scale, theorists such as Strauss and Howe have proposed that generational cycles that follow repeating patterns approximately every 80 years. This theory suggests societal events align in predictable rhythms akin to harmonic intervals in music. Historian Arnold Toynbee similarly posited that civilizations move through repeating stages, growth, maturity, and decline in rhythmic patterns. These historical cycles hint at a broader harmonic structure to social time, aligning our human experience with cyclical harmonic intervals similar to musical resonance. Mathematically, this harmonic patterning of time is supported through Fourier analysis, a technique that decomposes complex signals into the sums of simpler periodic elements. Fourier analysis has proven instrumental in identifying underlying cycles within various time-based datasets, from climatological patterns like El Niño cycles to economic trends observed in market fluctuations. Each of these identified cycles can be viewed as temporal harmonics, or fundamental patterns that repeat and combine to shape complex time experiences. Interestingly, neuroscience research supports the idea that the human perception of time itself is rhythmic. Brainwave frequencies ranging from delta, which is 0.5 to 4 Hz, theta, which is 4 to 7 Hz, alpha, which is 8 to 12 Hz, and to beta, 12 to 30 Hz, reflect rhythmic cycles underlying consciousness and cognitive processing. These brainwave patterns can synchronize with external rhythmic stimuli through entrainment, aligning internal biological rhythms with external cycles, much like musical harmonics aligning through resonance. Now let's discuss time in a Klein bottle. A Klein bottle folds through itself in a way that eliminates any true inside or outside. And when applied to temporal flow, this topology allows every movement to remain continuous while floating back across its own trajectory. Rather than a single line, time moves along a looping surface, reconnecting in patterns that repeat without forming rigid boundaries. The rotation of this structure induces motion that resembles a toroidal current. Energy and information circulate, producing layers of oscillations within the fabric of space-time. These oscillations form repeating bands similar to waveforms, but arranged in a higher dimensional curvature. As the Klein surface twists through a 4D space, the flow of time advances while spiraling back across its own track, creating intervals that echo previous states in altered form. These intervals act like octave jumps in music, similar themes expressed in higher or lower registers, yet operating across dimensions rather than through sound. Loops inside this geometry interlock through resonance. When two oscillatory pathways align on the Klein surface, they intersect at points of phase coherence, concentrating their energy and information. These intersections create conditions where sequences appear to recur with highlighted significance. From the perspective of an observer embedded in 3 dimensions, these alignments manifest as synchronicities, events that seem related beyond conventional causality. Rather than chance, these experiences may arise from harmonic crossings inside of a higher dimensional orientation. Understanding these interactions mathematically involves representing oscillations as standing waves constrained by the Klein topology. Fourier-like decompositions extend into non-orientable surfaces and allow each loop to be analyzed as a frequency component, contributing to an overarching temporal field. When frequencies align in simple ratios, the interference pattern intensifies, amplifying certain timelines and compressing others. This effect could explain why certain historical epochs accelerate innovation or collective shifts, as if riding a constructive harmonic peak in spacetime flow, or why other eons feel wholly disharmonious, with wars and earthquakes and chaos happening as decoherence in the timeline happens. We are at a harmonic trough in space-time flow. The Klein bottle's continuous surface also supports octave-like scaling in temporal perception. A sequence of events can recur at progressively larger scales, days echoes years, decades and centuries, because the topology carries similar self-patterns along its curvature. Each circulation alters the phase relationships, introducing variation without abandoning the structure. These nested recurrences generate what feels like cycles of destiny or historical rhythm, reflecting the geometry of the surface itself. An easier way to visualize all of this might be to think of pouring water into a vase. The flow of water flows around the vase, and then if you could keep that water flowing, and then nest that vase inside of another vase and have water flowing around that, and then keep that out. That's a nested structure of the flow of time, with multiple currents of time all running simultaneously within the structure of the 4D Klein bottle. Now, positioning consciousness within this structure brings an additional dimension of interpretation. Awareness might navigate along multiple strands of oscillation, accessing intersections where resonance heightens the informational density of experience. Memory, intuition, and foresight could operate as phase-related positions on the same surface, linked by harmonic intervals rather than linear progression, which means that progressive impressions or déjà vu may signal contact points where separate trajectories converge inside the Klein surface. Rather than flowing endlessly forward, time under this model folds and spirals in self-referential arcs, producing coherence across vast scales. Every oscillation participates in a pattern of patterns, ongoing harmonic architecture where past and future interlace through geometric necessity. Observing synchronicities through this lens means perceiving them as markers of resonance, evidence that the loops of higher dimensional surface have momentarily aligned, revealing the harmonic texture of time. Time forms a structure that moves in curves and oscillations, folding and circulating without boundaries. A Klein bottle offers a geometric model for this behavior, creating a continuous surface where every path reconnects while extending forward. Oscillations run along this curvature, generating sequences that spiral through layered loops. Each cycle shifts slightly, creating patterns that recur like octaves rising through different registers, carrying variation while preserving continuity. These loops intersect through resonance, forming points where oscillations align and amplify. At those intersections, information concentrates and experience intensifies, producing events that feel charged with meaning. Synchronicity reflects those alignments where cycles converge in a higher dimensional surface and expresses coherence across scales. History, biology, and personal experience trace these harmonics crossings, moving through intervals that organize complexity without imposing rigidity. Scientific observation supports this rhythmic structure. Sources are in the bio. Gravitational waves reveal oscillations in spacetime, quantum theory identifies systems that sustain periodic states, and cosmology explores models of expansion and contraction as recurring phases. Fourier analysis uncovers cyclical components hidden in climate records, economic trends, and neural activity. Brainwave entrainment demonstrates how consciousness synchronizes with external rhythms, showing that time perception itself follows harmonic principles grounded in oscillation and ratio. Consciousness navigates these dynamics by engaging with the intersections where patterns converge. Memory, anticipation, and intuition occupy positions linked by phase relationships rather than fixed by sequence alone. At those crossings, information density rises, creating conditions for insight, familiarity, or the sensation of repeating events. Awareness participates in this motion, shaping experience while remaining shaped by the underlying geometry of the universe, forming a reciprocal relationship between mind and temporal structure. Time emerges as a continuous harmonic field, layering cycles and resonances into an architecture without edges. Every oscillation contributes to a larger composition, carrying meaning through alignment and variation. These patterns extend across scale, connecting physical processes with perception and history through shared ratios. Understanding time through its harmonic order replaces linearity with geometry that organizes recurrence, turning the flow of existence into a structure of interwoven oscillations sustained by resonance. So that wraps it up for today. As always, sources are in the channel bio. Thank you so much for watching, and don't forget to like, subscribe, and ring the bell like the winners that you are, and I will see you next time. Bye!